Hello students, welcome back. Now in today's class, we are going to derive what is the coplanarity of two lines. That is equation, the coplanarity of two lines. So I consider two lines, let this will be line 1 and line 2. Before I actually start deriving, I am going to tell this figure or the diagram is not important here in your textbook. If you see, they have not given the diagram. Just for your understanding, I have written this. Okay, so let us start deriving this. So we have considered two lines. Let the given lines be, so we have taken, I am taking the equation of this as vector r is equal to vector a1 plus lambda times vector b1, and vector r is equal to vector a2 plus mu times vector b2. So this we have already derived in the starting classes of 3D geometry. So the equation of the line which is passing through a point and parallel to a given vector, where we got the vector form as vector r is equal to vector a plus lambda times vector b. Here also if you see the line L1, it is passing through the point A and it is parallel to a vector b1. So I have written the equation of the line L1 as vector r is equal to vector a1 plus lambda times vector b1. Similarly, if you see the line L2, it is passing through the point B and parallel to the vector B2. So let us write that. Let the line 1 passes through the point A with position vector a1 and parallel to vector b1. Similarly, the line 2 passes through the point B with position vector a2 and parallel to vector b2. Now, if I find the vector AB, then vector AB will be equal to vector OB minus vector OA, where vector OB, we have already told that for the point B, the position vector is A2. So vector OB will be equal to A2 minus, for the point A, the position vector is A1. So vector OA is equal to A1. So vector AB is equal to A2 minus A1. And if the two lines are lying on a plane, so the lines are coplanar if and only if they are lying on the lines. Sorry. No, so if we consider two lines, or if we say that the two lines are lying on a plane, okay, the thing is either the two lines will be parallel or they will be perpendicular. Now let us see the condition. The given lines are coplanar if and only if vector AB is perpendicular to vector B1 cross vector B2. This is what you should understand here. So we have considered AB vector. Okay. Now this vector v1 and v2 are not parallel to each other. That is, the vector v1 is not parallel to vector v2. They are. Vector v1 is parallel to the line L1. Vector v2 is parallel to line L2. These two vectors, vector v1 and vector v2, okay, they intersect in a plane. Okay. So when they intersect, if I am able to find, so if this is this for your imagination, so if this is vector v1 and you have vector v2, so if I extend this vectors, they may meet at particular point, and if I am finding the cross product between these two vectors, okay, then their resultant vector will be perpendicular to the plane. The resultant vector, that is, what is the resultant vector? It is v1 vector cross v2 vector will be perpendicular to the plane. That is what we are going to say. So when they are perpendicular to the plane, they will be like this. So I am going to write it like this. So this is vector v1 cross vector v2. Okay, when they are perpendicular, now you can see AB vector is perpendicular to vector v1 cross v2, because v1 cross v2 will be like this. So from that I am going to write as written as the given lines are coplanar if and only if AB, vector AB is perpendicular to v1, vector v1 cross v2. So we already know, if the two vectors are perpendicular, then the dot product between them is 0. So I can write this as vector AB dot vector v1 cross vector v2 is equal to 0. Now vector AB, what vector AB can be written as? We already see vector AB is vector A2 minus A1 dot vector v1 cross v2 is equal to 0, and this is the vector form for the coplanarity of two lines. Let's see its Cartesian form. Now let us derive its Cartesian form. So here let vector a1 be equal to x1 I cap plus y1 j cap plus z1 k cap. Vector a2 is equal to x2 I cap plus y2 j cap plus z2 k cap, and vector b1 is equal to a1 I cap plus b1 j cap plus c1 k cap. Vector b2 is equal to a2 I cap plus b2 j cap plus c2 k. So let us first find what is vector a2 minus vector a1. So vector a2 minus vector a1 will be equal to x2 minus x1 I cap plus y2 minus y1 j cap plus z2 minus z1 k cap. Now here, if you remember the scalar triple product, this is in the form of scalar triple product. So this you can consider as vector A dot vector B cross vector C. So how we used to find scalar triple product? We used to use the determinant the same way. So here determinant of, so the first row should be written the components of vector a2 minus a1. That is nothing but x2 minus x1, y2 minus y1, z2 minus z1. Next, the second row should be filled by the components of vector b1, which is a1, b1 and c1. So the third row should be filled with the scalar components of vector b2, which is a2, b2 and c2. This is equal to 0, and this is the Cartesian form for the coplanarity of two lines. Now let us solve a problem on this. So here in this problem we need to show that the given two lines are coplanar. That is, we need to prove the determinant of x2 minus x1, y2 minus y1, z2 minus z1, a1, b1, c1, a2, b2, c2 is equal to 0. This is what we need to prove. So here in the derivation, I have used the vector form of the equation of the line. So here in the problem, they have given its Cartesian form, and we already know what is its Cartesian form. Cartesian form is given by x minus x1 by a1, which is equal to y minus y1 by b1, which is equal to z minus z1 by c1. I am writing a1, b1, c1 and x1, y1, z1. Why? Because we are considering two different lines. So if I compare this with the first equation, x plus 3 by minus 3 is equal to y minus 1 by 1 is equal to z minus z1, so z minus 5 by 5. We will be able to find, or we will be able to know what is the value of x1, y1, z1 and similarly x2, y2, z2. Similarly, the second equation in its Cartesian form can be written as x minus x2 by a2, y minus y2 by b2 and z minus z2 by c2. So comparing the given second equation from the problem with this, we get what are the values of z1, x2, y2, z2 and a2, b2 and c2. So here, if you compare, we'll be able to find what are its values. So let us substitute in the formula. The formula is given by x2 minus x1, y2 minus y1, z2 minus z1, determinant of x2 minus x1, y2 minus y1, z2 minus z1 in the first row. In the second, a1, b1, c1 and in the third, it is a2, b2 and c2. So let us substitute, let us find what is x2 value. So let us compare. The value of x2 is equal to minus 1 because the general equation is given by x minus x2. But here we have x plus 1. So plus 1 is, this can be written as x minus of minus 1. Hence the value of x2 will be equal to minus 1. Therefore x2 value is minus 1. Minus x1 value. Can you now tell me what is the value of x1? It is minus 3. So 1 minus, minus 1 minus of minus 3. Then y2 minus y1. y2 value is 2 minus y1 value is 1. Next z2 minus z1. z2 value is 5. Then z1 value is also 5. Next a1, b1, c1. A1 is minus 3, B1 is 1, C1 is 5. So minus 3, 1, then 5. Let us write what is A2, B2, C2 values, which is minus 1, 2 and 5. So here let us simplify this. So the first row, minus 1 plus 3. Minus 1 plus 3, it is plus 2. 2 minus 1, 1. 5 minus 5, 0. Next we have minus 3, 1, 5. Minus 1, 2, 5 in the third row. Let us expand this along the first row. So expanding along the first row, first we should write the first element 2 into, now neglecting the corresponding row and the column. So we get, so 1 into 5, it is 5, minus 2 into 5, which is 10. Next minus, writing the second element of the first row, which is 1. Then neglecting the corresponding row and the corresponding column, that is the first row and the second column. Next we should multiply minus 3 into 5, it is minus 15, minus 1 into 5, which is minus 5. Next plus the third element of the first row, which is 0. Next neglecting the first row and the third column, we get minus 3 into 2 is minus 6, minus 1 into 1, which is minus 1. So let us simplify this. 2 into 5 minus 10, it is minus 5. Then minus 1 into, see here, minus 15 plus 5. Minus 15 plus 5, it will be equal to minus 10. Next 0 into any value is 0. So 2 into minus 5, minus 10. Minus 1 into minus 10 plus 10. Minus 10 plus 10 is equal to 0. So we got the answer as 0. This proves that the given two lines are coplanar. Next, let us see what is the formula for the distance of a point from a plane. So here I am going to consider a point P, and the position vector of this point P will be vector A. Next, I am going to consider a plane and I call this as plane phi 1, and the equation of this plane phi 1 be vector r dot n cap is equal to d. If this is the equation of a plane, this is nothing but the equation of a plane in its normal form. Means, in order to find the equation of this plane, we already know what is the distance from the origin to the plane, perpendicular distance from the origin to the plane. So we know what is the perpendicular. So this will be n and this will be the distance d from the origin to the plane. Okay, let us write this. Let us consider a point P with position vector A, and also the plane phi 1 whose equation is vector r dot n cap is equal to d. After this, I am going to consider another plane phi 2 which is passing through the point P and parallel to the plane phi 1. So, I am going to consider the second plane and I call it as plane phi 2. It is such that it is passing through the point P and also parallel to phi 1. Consider another plane phi 2 which passes through the point P and parallel to plane phi 1. And if you see, now this becomes, now I call this as n dash, and you can see the unit normal vector which was for phi 1 is same for also the plane phi 2. The unit normal vector for the equation phi 1 was n cap. Now again, the same n cap is the unit normal vector given for the plane phi 2. Therefore, the unit normal vector of phi 2 is also n cap. Okay, now let us write what is the equation of the plane phi 2. Now if you see plane phi 2, this also we have derived already. This is nothing but the equation of the plane which is passing through the point and perpendicular to the given vector. What is the given vector here? It is n cap. So it is passing through which point? P, whose position vector is vector A, and it is perpendicular to the given vector O n dash. So now I can write the equation of the plane phi 2 as, therefore, equation of plane phi 2 is vector r minus vector A dot n cap is equal to 0. Therefore, I can write this as vector r dot n cap minus vector A dot n cap is equal to 0, or vector r dot n cap is equal to vector A dot n cap. And this becomes the equation of the plane phi 2. So I can write this as vector r minus vector A dot n cap is equal to 0 is the equation of the plane phi 2. Now you see, let us compare this, that is the equation of the plane phi 2 and the equation of the plane phi 1. If we compare, D is the distance of the plane pi1 from the origin to the plane. D is the distance from the origin to the plane. Similarly, if you see the equation of the plane pi2, there A dot n cap will be the distance from the origin to the plane pi2. Compare both the equations. If D is the distance from the origin to the plane pi1, on comparing, vector A dot n cap will be the distance from the origin to the plane pi2. From the origin to the plane pi2. Here you can take ON is the distance from the origin to the plane pi1. Similarly, ON dash will be the distance from the origin to the plane pi2. Therefore, D is the distance of the plane pi1 from the origin, and similarly vector A dot n cap is the distance from the origin to the plane pi2. Hence, the distance of the plane pi1 from origin is equal to magnitude of vector A dot n cap. We should take magnitude. Therefore, the distance of the point from the plane will be equal to. Now, actually, what we need to find is the distance from this point P to the plane pi1. We should find. We need to find this distance. In order to find this distance, see here the total distance, that is ON minus ON dash. ON minus ON dash, if I do, I get the distance P to Q. The distance from a point P to the plane can be found by subtracting ON minus ON dash. Therefore, this will be equal to ON minus ON dash. What is ON? ON is nothing but the distance from the origin to the plane pi1, and we already know that is nothing but D. Minus ON dash, it is nothing but the distance from the origin to the plane pi2, and we already found that is equal to vector A dot n cap. As we are finding the distance, it should be magnitude of vector D minus vector, not vector D, it is D minus vector A dot n cap. So here, this is the distance of a point from a plane. If the equation is given in this form, that is, if the unit normal vector is given. If only the normal vector is given, then what is the distance of a point from a plane? That is C. So, instead of vector R dot n cap is equal to D, if the equation of the plane pi1 is given in the form vector R dot vector n is equal to D, then the distance of the plane pi1 from origin, okay, will be equal to modulus of D by magnitude of vector n. Why? Because we need to divide. What here we have considered unit normal vector, that is vector n by magnitude of vector n. So we are dividing that by the normal vector, magnitude of normal vector. Similarly, the distance of the plane pi2 from origin will be equal to vector A dot vector n by magnitude of vector n. So vector A dot vector n by magnitude of vector n. If you remember, it was only vector A dot unit normal vector n cap. So here, since instead of unit normal vector, they have given only normal vector, they are going to divide by its magnitude. Therefore, now you can easily tell what is the distance of a point from a plane. That will be now equal to modulus of d by magnitude of n cap minus vector A dot vector n by magnitude of vector n. So here we can take magnitude of vector n as LCM. We'll get d minus vector A dot vector n in the numerator. Since it is modulus, I can write this as vector A dot vector n minus d by magnitude of vector n. This formula you should remember. So this is the distance of a point from a plane, which is vector A dot vector n minus d by magnitude of vector n. Now let us find its Cartesian form. So here in the Cartesian form, let vector A be equal to x1 I cap plus y1 j cap plus z1 k cap, and vector n is equal to ai cap plus bj cap plus ct cap. Okay, therefore the Cartesian form is given by, it is the distance of a point from a plane will be equal to, now modulus of vector A, which is x1 I cap plus y1 j cap plus z1 k cap dot vector n. So this I'm going to write it down. So this will be equal to, it is x1 I cap plus y1 j cap plus z1 k cap dot ai cap plus bj cap plus ck cap minus d, can even use small letter d, by magnitude of vector n. Therefore, that is nothing but root of a square plus b square plus c square. Okay, as I have used the Cartesian equation of the plane here, so I am writing even d capital. So it is x7 I cap plus y1 j cap plus z1 k cap dot ai cap plus bj cap plus ck cap minus d. Simplifying, that is finding the dot product between the two vectors, we get a into x1 plus b into y1 plus c into z1 minus d divided by root of a square plus b square plus c square. And this is the Cartesian form of the for the distance of a point from a plane. That is, if the equation of the plane is given in its Cartesian form, then you can use this formula. Let us solve the problems. So here we need to find what is the distance of each of the given points to the corresponding plane. So they have given for the first problem, the point is 0, 0, 0 and the plane is 3x minus 4y plus 12z is equal to 3. So here the point is x1, y1, z1 and the equation is ax plus by plus cz is equal to d. And we already know what is the formula. D is equal to, it is a into x1 plus b into y1 plus c into z1 minus d divided by root of a square plus b square plus c square. So further let us substitute. So x1 value is 0, y1 is 0, z1 is 0 and the value of a is 3, b is minus 4, c is 12 and d is 3. So now this will be equal to 3 into 0 plus of minus 4 into 0 plus C value is 12 into Z1 value is 0 minus what is the value of D? Is this 3 whole divided by root of A square plus B square plus C square. A square 3 square 9 plus B square minus 4 whole square 16 plus C square. It is 144, 12 square. Therefore, this will be equal to modulus of minus 3 divided by root of, that is 9 plus 16 plus 144, 169. Therefore, this is equal to 3 divided by root 169, that's nothing but 13. So, since we are finding the distance, we should not have any negative sign. So, 3 by 13. Next question, similar type. Again, they have given a point and the plane. So, point is nothing but your x1, y1, z1, and the plane is ax plus by plus cz minus b. Here, see here, this can be written as, so you can write this equation as in the form of 2x minus 3y plus 6z is equal to 2. So now the equation reduced in the form ax plus by plus cz is equal to d. Again substituting in the formula. So I am directly substituting. So what is the formula? A into x1. A value is 2. X1 value is minus 6 plus B into Y1. B value is minus 3, Y1 is 0 plus C into Z1. C is 6, Z1 value is 0 minus D. D value is 2. Whole divided by, now next you have the root of A square plus B square plus C square, 2 square 4, 3 square 9, 6 square 36. So this will be equal to 2 into minus 6, which is minus 12. Next we have 0, this also 0, minus 2, whole divided by, so it is 49, root 49. So minus 12, minus 2, which is nothing but minus 14. So modulus of minus 14 divided by 7. So if you simplify, this will be minus 2. Modulus of minus 2 is nothing but plus 2. Okay. So the next problem, again you have a point and a plane. So substituting in the formula, so we have D is equal to AX1. So can you tell me what the value of A is? The value of A is 2, X1 value is 3. Next plus B. B value is minus 1, that is the coefficient of Y. Then Y1 value, which is minus 2. Then plus C. C value is the coefficient of Z, which is 2. And Z1 value is 1 minus, what is the value of D here? It is nothing but minus 3. So this, if I rewrite the equation, this will be 2x minus y plus 2z is equal to minus 3. Be careful while writing the value of D. So here D value is minus 3, whole divided by root of A square, 2 square, 4 plus B square minus 1 whole square, which is 1 plus C square, 2 square, it is again 4. So this is equal to modulus of 2 into 3, 6. Then minus 1 into minus 2, it is plus 2. Then 2 into 1, it is 2. Minus into minus plus 3 divided by, it is root 9. Therefore, on simplifying, we get 13 divided by 3. Okay, the last problem, let us solve. So here, substituting in the formula, so we get it as A, which is 1 into x1, which is 2, plus B, which is 2, y1 value 3, plus C, which is minus 2, z1 minus 5, minus B value is 9, whole divided by root of A square, 1 square, 1, B square, 2 square, 4, C square, minus 2 whole square, which is again 4. Therefore, this is equal to modulus of, we get 2 plus 6 plus 10 minus 9 divided by root 9. Therefore, which is equal to, so 10 minus 9, it is 1. So 6 plus 2, it is 8. 8 plus 1, it is 9. 9 by 3, therefore 9 by 3 is equal to 3. Okay, I hope you have understood the derivations and also the problems.